exponent, but just in general, a radical equation, somewhere under a square root or cube root, maybe fourth root, you will have a variable somewhere underneath there. What we're going to do, our next lesson, we will do the other type of equation, and that's when you have a rational exponent. You won't see any of those today. We're just going to work with radical, an actual like square root, cube root, fourth root today, and we'll do the other kind on Monday. So, just in general, if you're solving a radical equation, you want to get the radical alone on one side. So that could be a square root, a cube root, a fourth root. I don't think I have anything bigger than that on any of the notes, homework, quizzes, tests, anything like that. But you're going to get the radical all by itself on one side. And then it's going to depend on the type of radical that you have. But you'll take both sides of your equation. So I'm going to write take both sides to the power of, I'm just going to kind of write this formally, the index of the root. So you're going to take both sides to the power of whatever the index of the root is. So what I mean by that, like if you're working with the square root, you square both sides. If you're working with the cube root, you take both sides to the third power to cancel it out. If you're working with the fourth root, you take both sides to the fourth power to cancel it out. The main tricky part is you got to get the radical alone first and then apply that squared, cubed, fourth, whatever you're working with in the problem. Okay, so I just have a bunch of different radical equations. Each one's a little bit different here. My first one is a square root, so I've got 2 and then times the square root of 5x minus, or 5x plus 1, all that under the square root, and then minus 10 equals 2. If you're looking at that problem, you're trying to get the square root alone, what would you do first? You try to get the square root alone, what would you do? Perfect, let's add 10. All right, so add 10. All right, so I got 2 square root of 5x plus 1 equals 12. What would you do next? Yeah, divide by 2. All right, so I've got square root 5x plus 1 equals 6. Okay, now you cannot like divide things out of, subtract things out of, take things out of the square root. What you want to do once you get that square root alone is you want to cancel the square root out. So all you got to do, if you're working with a square root, we're just going to square both sides. All right, so I'm just going to end up, and you just square root and squared cancel each other out, so you just copy down what was under the square root, and I actually have to square the other side, so 6 squared would be 36. And then from there, usually the equation's not too bad to solve. We're just going to maybe have to do a couple steps. So I'm going to subtract 1 here, get 5x equals 35, divide by 5, and x is just going to end up being 7. And that's it. That's all you have to do. The question right next to this, I got negative 10 plus the cube root in this question, 2x plus 1 equals negative 5. What would you do first for that problem? Negative cube root. So how would I go about add 10? Exactly right. And add 10. That 10's being subtracted, so you're going to add it to the other side. All right, I got a cube root, 2x plus 1 equals 5. Now, make sure you pay attention to the root. So we're working with a cube root, so we're going to take both sides to the third power. Again, just like a square root, you cannot add, subtract, divide, multiply things out from underneath. You just have to actually cancel out the root by taking both sides to the power of the index. So third root, third power cancel each other out, and this is just going to become 2x plus 1. And then actually figure out 5 to the third, which is 125. And then from there, it might be a couple more steps. I'm going to subtract 1 here. Got 2x is 124, divide by 2, and x is going to end up being 62 for that question. What would you do first on the next one? I've got 6 plus 4 times the square root of x equals 50. Thank you. Okay, I put this on here on purpose. I don't know why, sometimes people are just tempted to like take that 4 and 6 and add them together, but do not do that. And you guys, obviously, that's not what he said to do. He said subtract the 6. Do not put those together. You want to move that 6, you're just subtracting it. So you're going to get 4 times the square root of x is equal to 44. All right, now here, I got to isolate my radical. So I don't want that 4 in front of it. It's being multiplied. So you're just going to divide both sides by 4 to get rid of that. And then you'll have your square root by itself. This one is just the square root of x. So after we square both sides, we're just going to be done with this question. So square root and squared cancel each other out. This will just be x. And then 11 squared is 121. Is anybody having a question? Okay, the rest of these from here on out are a little bit trickier than the ones we just looked at. So let me scooch this up a little bit. Now, in the next example, I've got square root and then x squared plus 3. First thing I want to tell you about that, you can't just go, oh, square root and squared and cancel that out. That doesn't work that way. The square root works like a grouping symbol. So you would have to add x squared to the 3 first. So you can't just cancel the squared out there, okay? You have to add it to the 3, and we can't do that. So what I need to do there is cancel the radical out. So don't just cross that out. If you got pluses and minuses in your radical, you can't cancel things with some of the simplification we've been doing. So what I want to do there then, the radical's already by itself. I just want to square both sides. Now, square root and squared cancel each other out. So this would just stay x squared plus 3. Now, what would you do to simplify the other side? If I'm going to do x plus 1 squared. Yes, please don't distribute. Please don't. Any pluses or minuses, you want to multiply that by itself, so you got a FOIL. And if you don't, you're going to miss out that middle term, and that'll mess up your answer. So, got a FOIL. So, x plus 1 squared is x plus 1 times x plus 1. So, however you want to do it, I just think of it as a little double distributive property. If you want to do a box, that's totally fine. I just know I got to multiply x by both of these terms and 1 by both of these terms in the second set of parentheses. Should get x squared plus 1x, I'm just going to write x, then you get plus another 1x, and then we're going to do 1 times 1, which is not 2, which is what I wrote last period, don't judge, it's 1. So 1 times 1 is going to give you 1, and I'm just going to bring down that x squared plus 3. If you combine like terms with your quadratic, it should be x squared plus 2x plus 1. And actually what's really nice on this particular question, if you try to get all your x squareds on one side, you just have 1x squared on both sides of the equation. So when I try to move it, it just cancels out on both sides. So I don't have that anymore. And I end up with 3 is equal to 2x plus 1. So the x squareds just cancel each other out, just trying to combine like terms there, but they go away on both sides. So then all I have to do here, we're just going to move the 1, subtract it. So I get 2 equals 2x. And then we'll just be dividing by 2, and our answer is going to be 1. Is anybody having a question? Okay, now the last one's kind of tricky because there's 2 different radicals in the same equation. If that's the case, if you have 2 different radicals in the same problem, to isolate, what you want to do is try to get 1 on one side of the equation and 1 on the other. To do that here, I would literally just add this 3 times the square root of x minus 5. I'm just going to add that whole thing, completely legal, to the other side of the equation. So then my problem would be square root of 4x minus 10 equals, now this has a 3 in front of it, and that's still there even though I moved it to the other side. So I have a 3 in front. That's okay. I can't get it totally isolated the way that is. Where I would just have a square root on each side, but I can still cancel them out by squaring. All right, so we isolated it as much as possible. What I left on the left side there would just be 4x minus 10. What would you do if you square the other side? I've got 3 times the square root of x minus 5. If I square that, what's that going to look like? Yeah. Exactly. This is a product. So you're just going to, it's not a FOIL or anything, it's just you're going to square the 3, so you're going to get 9. And then whatever's in there, the radical, you just put it in parentheses because you got to multiply 9 by that, but the square root and squared are still going to cancel each other out. So it's not too bad to do. It's just 4x minus 10, 9x minus 45, little distributive property there. And then however you want to do this, there's multiple ways to solve. I like to try to keep my variable positive if I can. So if it was me, I would subtract 4x from both sides. And I'm just going to do this right in the same step. I'm going to add the 45. That'll move all the numbers to one side and all the variables to the other. So I'd get 35. 9x minus 4x will give you 5x. Divide by 5. And x is going to be 7. Okay. Does anybody have any questions? Okay. Now, on the back, we're going to do a little bit trickier situations. We haven't seen anything like this on the front, so I hadn't brought it up until now. But these equations and the ones we're going to do in our next lesson also, they do have the potential for what we call an extraneous solution. An extraneous solution literally has the word extra in the word. This is an extra answer that doesn't work in the original problem. You didn't do anything wrong, you did all the algebra correctly, but there's certain operations that can introduce the potential for one of these extraneous solutions. We've talked about this a little bit before when we had absolute value equations. It can happen there. And the case where it can happen with what we're going to work on specifically, because we're focusing on radicals here. So this is what you want to look for in these equations for an extraneous solution. So a square root cannot be equal to a negative number. Like a fourth root cannot be equal to a negative number. Remember when we were talking about this, we were talking about we would use I for that. So just in general, like if the index of your root, so I'm going to say I have an even index of my root, it cannot be equal to a negative number. I think for sure you'll see square roots, maybe a fourth root. I don't think there's anything bigger than that. But if you had a sixth root or an eighth root or anything like that, those cannot be equal to a negative. So let me just, like, if I give you a tiny example. So like if I say square root of 25 to you, you would just tell me that's 5, right? You would not tell me that's negative 5. We're not going to have any pluses or minuses that are already in the equation. The radicals are already there, so you wouldn't be introducing a square root for any of these problems. So just keep that in mind. There's no way for me to take a square root and get a negative or a fourth root and get a negative. That would not happen. So on my very first question in this example underneath here, if I just subtract 8 real quick, just like we were doing on the front, trying to get that radical alone, I'd get square root of 7x is equal to negative 6. Now if this is me, who's been a math teacher for a million years, I immediately know right then and there I have a square root equal to a negative. So I would just stop right there and I would say no solution. Now this is you guys maybe just learning this for the first time today. So let me keep going. Let's pretend I had this, and I'll just show you why that the answer doesn't work in the original problem. So if you just would keep going, if you would square both sides here, that's where you can introduce the potential for the extraneous solution, because when I square that, it cancels out that negative. I would end up with 7x, and then negative 6 times negative 6 is positive 36. This is where your potential for your extra answer gets introduced. Now, this does not have a nice answer because it's 36 over 7. But if I actually plug that back into the original problem, let me grab a different color here. Okay, so if I took this, right, and I plugged it in right here, you would have square root 7 and then 36 sevenths. I promise this is not bad, equals negative 6. That would be just to check this. When you take 7 times that 36 over 7, the 7s actually cancel, but this would be telling you 36 equals negative 6, and it would be positive. So this is not true. So that's why if you get a square root equal to a negative, just check it real quick. Or maybe if you just get a square root equal to a negative, I would just stop right there. But if you don't notice that, just check real quick and you'll see that that's not actually true. Square root of 36, it should be positive 6. So just be careful with that. That's just got a number. The rest of these, you're going to have to check your answers. So the rest of these, you have a square root equal to an expression. This next example just has a plain x by itself. but I have to check and make sure whatever I get for x there, I can't have a square root equal to a negative. So I'm just going to check my answers. If you have an x, or if you have any kind of an expression with a variable equal to a square root, you just got to check your answers. Everything else works exactly the same way. I'm just going to square both sides to cancel out the square root there on that next question. This will be 3x plus 10, and that'll be equal to, if I square x, that becomes x squared. Now, you are going to see this, that we'll have some of these questions that'll end up being a quadratic. So I promise anything that's quadratic will be factorable if you want to factor it. So to solve this, what I'm going to do, I'm going to set this equal to 0. And if you do want to factor, you want to keep your squared term positive. If you want to factor. If you want to use quadratic formula, you don't need to worry about that. But if you want to factor, keep your squared term positive. So I'm going to subtract the 3x and subtract the 10. And like I said, if you want, I'll use the quadratic formula on the next just as an example here. But I promise anything I'm going to give you will be factorable. Can anybody think for this one of two numbers that multiply get negative 10 and get negative 3? Yes, ma'am. Negative 5, positive 2. Okay, now my actual answers, remember, what sets the little parentheses equal to 0? So this would be 5, and this would be negative 2. Okay, now, because I had my square root and it was equal to an x or an expression, which is what's going on here, this is where I would go back when you have the radical all by itself before we squared it. This is where I would check. And you really just have to make sure I don't have a square root equal to a negative. So for this question, like if I plug in 5, it doesn't matter whether it's what the number is, it just matters whether it's positive or negative. So if I just put in 5 for x, 5 is a positive number, so we're good to go. So that answer works. If you plug in negative 2 to check, though, that would be a square root equal to a negative 2, and you cannot have a square root equal to a negative number. So this just has one solution. It would be the 5. Negative 2 would be what we would call an extraneous or an extra solution. You don't have to write that down or anything, but your answer to the question would just be 5. So just check. Okay, let me have you look at the next one here. Now this one, we're going to get a quadratic on this one. I'm going to use the quadratic formula just as an example for another option for how to solve this. I do want to isolate the radical first, so the first thing I'm going to do is I'm going to move that 2x that's being subtracted to the other side. So I got 11x plus 3 equals 2x. Okay, now when you square both sides here, we're just going to use some exponent properties on the right side. We're just going to end up with 11x plus 3 here. When you square 2x, you have to square the 2 and the x both. So that should end up being 4 and then x squared. All right. Now, if you guys want to factor this, you can. This would be using that little Berry method, which we haven't used in a while. Maybe we used it a little bit in our last unit, maybe. But 4x squared minus 11x minus 3. If you don't like that, I think it's a little harder to factor when you have a number in front of the x squared. Some people are really good at it. Some people, it just takes them a little bit. So just as an example here, I will promise you can factor all these, but if you want to use the quadratic formula, you could do that too. So if I have a quadratic equal to 0, if I do, hopefully you guys remember this, opposite of b would be 11 plus or minus square root. B squared would be negative 11 squared here, minus 4 part of the formula, times your a value, which also happens to be 4 here, times your c value, which happens to be negative 3. Everybody over 2a, so 2 times 4. So you can factor if you want to, use that little Berry method, or you can use quadratic formula. And usually what I do, I just try to figure out what's under the square root there real quick. So I'm just going to do 11 squared minus 4 times negative 3. And because I promised you guys these would all be factorable, if you're doing this question right, if you do use the quadratic formula to solve any of these instead of factoring, you should get a perfect square under the square root if you've done it correctly. And 169, the square root of that is just 13. So if I do 11 plus 13, that's 24 divided by 8, that'll be 3. If I do 11 minus 13, that'd be negative 2 divided by 8 would be negative 1/4. And then I had, let me go back here, I'll circle kind of where I would tell you to go. I would go back here where you had your square root alone, and that's where I would check. I just cannot have a square root equal to a negative number. So let's check this real quick. If I plugged in 3, right, 2 times 3 is 6, that's positive. It doesn't matter what the number is, as long as it's positive, it's good. So the 3 would work. I also need to make sure if I plug in negative 1/4, sorry, I'm drawing all over the place, I can't have a square root equal to a negative number. So if I do 2 times negative 1/4, that's going to be negative 1/2. And again, it doesn't matter what the number is, it just matters if it's positive or negative. So this is negative, so that's not going to work. That's going to be my extraneous solution there. You can have a situation, maybe both of them work, maybe neither one of them work, maybe you have one of each. It just kind of depends on the problem, so that's why you have to check. All right, I'm going to have you guys try and do this last one. And if you want to factor it, you can, or if you want to use quadratic formula, you can, but it is going to be a quadratic. What I would do here first, just to isolate the radical real quick, I'm going to add the 5 to the other side. So we're going to have square root 3x plus 13 equals x plus 5. And then just please don't forget this. You're going to square both sides. You have to FOIL that x plus 5. All right, and as you go through, when you get your 2 answers, and either factor or use quadratic formula if you want to, you want to check right here where you had the square root by itself. In this case, whatever your x value is, as long as if you add 5 to it, as long as it's positive, you're good. So your answer plus 5, if that's a positive number, you're good. Your answer plus 5, if that's a negative number, it's going to be an extra solution. So you guys just go ahead and try this real quick. Try this real quick. On this last question, both of these answers do work. So you get like the 3x plus, I saw a couple people have a little bit of a weird FOIL. So it should have been x squared plus 10x plus 25. If you want to set that equal to 0 for quadratic formula, or if you want to do factoring, either way, x squared, this should be plus 7x plus 12, which would be 3 and 4 as your factors, and actual answers would be negative 3 and negative 4. Now, you want to plug it, like when you have the radical alone, and some of you guys had extraneous, so be careful with this. If you plug in, this is not just a plain x. It's a square root equal to x plus 5. So you got to think about this for a second. If you take negative 3 plus 5, right, that would be 2. As long as it's a positive number, it doesn't matter, that will work. It just can't be equal to a negative. If I plug in negative 4 plus 5 is positive 1, as long as it's positive. And this is a situation where actually both of the answers work. So that question would have 2 different answers that you could use. All right.